If you've made repeated observations over time, or if you've made multiple observations on a single occasion, and you wish to analyze those dependent data using perhaps a dependent t-test, repeated measures ANOVA, or perhaps a sign test, you can instead use this ordinal analysis concatenated orderings procedure in the OM software. Now for this example, we're going to look at these data in which we have positive, neutral, and negative ratings. Now these are actually averages of ratings made on a 1 to 5 point scale to multiple stimuli. And we'll just look at the positive and neutral values or orderings for this example. Now the expectation for the researchers here was that the positive score should be higher than the neutral scores. So that's the expectation. Now we can see in our analysis, just to orient ourselves to the window here, we can select the data set that we wish to analyze. Here we're looking at this affective realism data set. Here we get the list of orderings that we can analyze. We can always sort these alphabetically by selecting this button here. If we select it again, it sorts them back as they're presented in the data edit window. If we want to find a particular ordering, if we have a long list here, we could use this filter. So let's say we're looking for something that has the letter G in it. We can type in capital G. Now, it is case sensitive, and that will find any ordering that has a capital G in it. I'll just blank it out here and then hit enter. There's our original list. We see the concatenated orderings over here. We can separate those by a grouping ordering. And then the bottom part of the window here, we have our options, the randomization tests, and the output. And we'll explore all of these details and further in subsequent videos. But for now, let's analyze the positive and neutral orderings. So I'll move those over and we're going to concatenate those, put them side by side. We'll go to the define pattern option here rather. And I'm going to magnify this so we can see what's going on a little bit better. So notice we have highest and lowest, and then we have positive and neutral. So we have the positive and neutral orderings concatenated side by side. Now what is the ordinal expectation? Again, the ordinal expectation is that the positive scores should be higher than the neutral scores. I don't worry about magnitude or care about the magnitude of that difference so much, just as long as the positive is greater than the neutral. So what this analysis is going to do is just work through each individual case and check out that hypothesis to see if it matches. So for example, for the first individual, the positive score is 3.167, or yes, 167. The neutral is 3.10. So that matches expectation. So for that person, those values would be counted as a correct classification. The second individual, 3.33 to 3.27. So again, the positive is greater than neutral. That's a correct classification. The third person, 2.78 to 2.87. So there, the positive is less than neutral, so that is an incorrect classification. So the algorithm is just going to work through all 45 cases here and tally up the number of correct classifications. How many individuals match this ordinal prediction as we see in this pattern here? So we'll select OK to accept the pattern. Now I'm going to turn off the pairwise results because we only have 2 orderings that we're looking at here, so that will be redundant. And I'll just select OK to accept all the defaults and run it. So we're taken to the text output window, and here we see all of the options that we've chosen. We'll cover each of these in separate videos. We get our ordering frequency summaries. I'll talk about how I've defined the orderings again in subsequent videos. Here we get the define pattern. So you can see the little blue crosses here. So the positive, again, is expected to be higher than the neutral. We have 45 cases under analysis here. And then we get the classification results. So I'm going to just hit enter here a little bit to scroll this up, just to bring it to the center of the screen. And we get the classifiable pairs of observations. So notice the label here, ordinal relations between pairs of observations classified according to the defined patterns. So we have 45 individuals, and of those, 26 matched that ordinal prediction. If you turn that into a percentage, you get this percent correct classifications index, and it is 57.78. So a little over a 50-50 split here, about 58% for the correct classifications index. And we also get these classifiable complete cases. Now in this instance, with only 2 orderings, this is redundant, so we're getting the exact same values. But as you can see, it's just a simple, straightforward analysis. You're setting up a predicted ordinal pattern, and then you're going through and just counting the number of individuals who match that ordinal expectation. And you report that as a percent correct classification index. There's much more we can do in this analysis, and we'll see that in subsequent videos.